have cover material today that you will need to know on the Chapter 2 exam to help you prepare for the exam. These are questions that will be similar to what you will find on the exam. If you would like some further examples of problems worked out, you can follow the link on the Blackboard website that takes you to the YouTube videos that go along with our textbook. An example of a problem that you might see would be something like this, where you're trying to find the absolute value of a number. And remember, the absolute value is the distance that number is away from 0. So for example, for negative 13, we want to know how many spaces away from 0 is that on the number line. And I've drawn the number line here with 0 and negative 13, and it is 13 spaces away from 0. So in this case, the absolute value of negative 13 is simply the number 13. And this works for positive numbers as well as negative numbers. The absolute value is always going to be a positive quantity. If I have a different problem, say I want to find the absolute value of the number 5, again, I want to know how far is that number away from 0 on the number line. So if I have 5 there, it is 5 spaces away. So again, the absolute value is always a positive quantity. Another type of problem that you're going to find on the exam are going to be things like this, where it's going to ask you to find negative x when x equals a certain number. So the negative tells us that is the opposite of whatever number you have for x. So in this case, the negative of x would be the opposite of 17, which is negative 17. So our answer here is simply negative 17. Now if we have a different number for x here, we're going to say x is negative 15. The negative in front of the x is telling us we want to find the opposite of x. So we want to find the opposite of negative 15. So we have the opposite of negative 15, which is simply the number 15. If we get it a little trickier and we want to find what the opposite of x is, and in this case, if x is equal to negative 15, I'm going to put in, I want to find the opposite of the opposite, and instead of x, I'm going to put negative 15. And I can simplify what that all is by saying, okay, the opposite of negative 15 is 15, and then I've got this other negative sign here that I still need to account for. So I'm going to find the opposite of 15, which is negative 15 in this case. Another type of problem that you're going to find is where you're going to be needing to add integers. Something like this. I have negative 1 plus 7. If it's helpful for you to refer to the number line, go ahead and do that. You're going to find your first number, in this case negative 1 on the number line, and you're going to, when we're adding integers, we're going to go to the right. So if we're going to go 1 space, 2, 3, 4, 5, 6, 7, that's where we're going to land. So we started at negative 1, we went to the right 7 spaces, and we end up at 6. So negative 1 plus 7 equals a positive 6. When we are adding a negative number to a negative number, as in the case negative 6 plus negative 3, we can again look at the number line. We've got negative 6 there, 0 there. When we're adding a negative number, we're going to start at this number, this negative 6, and if we're adding a negative number, we're going to go to the left. So we're going to go to the left 3 spaces. We start here, 1, 2, 3. This takes us to negative 9. So negative 6 plus negative 3 gives us a negative 9 for our answer. And we can do this with multiple numbers. We can do it with 3 or 4 or 5 numbers, however many we have, and we want to add together. So if we have negative 14 plus 2 plus a negative 7, so some of these integers are positive and some of them are negative, we can go ahead and look at adding these two together first. Negative 14 plus 2 is going to give us a negative 12. And then we'll add on that negative 7. So I have simplified my problem, and I'm working through it so I don't lose my place, so I keep track of everything along the way. And now I can think, okay, negative 12 plus a negative 7. Remember, I'm going to the left. I'm becoming more negative when I add a negative number here. So my answer in this case is negative 19. Now when I want to subtract integers, something like 14 minus 6 is the subtraction that we've done since we were children, and we know that the answer to that is 8. But we're going to deal with negative and positive integers for some of these problems. So if I have a negative 4 and I'm going to subtract 2 from that, again, I want to think back to my number line. I'm going to start at negative 4. So there's my negative 4 on the number line. And subtracting 2 is the same as adding a negative 2, which means I'm going to the left 2 spaces, 1, 2, which gives me a negative 6. So negative 4 minus 2 is a negative 6 for the answer. Now what about when I want to subtract a negative number, as in the example 7 minus negative 5? Now whenever we subtract, subtraction is the same thing as adding the opposite. So I can rewrite this as adding the opposite, and the opposite of negative 5 is a positive 5. So I can change this problem around. Instead of having subtract a negative number, I can add a positive number, and it's a lot easier to work with. Now I simply have 7 plus 5, and that equals 12. And again, I can do multiple subtractions and additions together. So if I have something like negative 12 plus 6 minus a negative 2 plus 10 minus 7, I'm going to work this in parts and keep rewriting the problem so I keep everything straight. So I'm going to first look at these two together. Negative 12 plus 6 gives me a negative 6. And then I can rewrite the rest of the problem, making sure that I'm copying it correctly so I don't make a mistake along the way. Now I'm going to look at these two parts, negative 6 minus a negative 2, and I can think about that as adding the opposite. So I can say negative 6 plus 2, that gives me a negative 4, and then I have all this other stuff here that I'm going to get to next. Now I'm going to look at this and say negative 4 plus 10 gives me a positive 6. I still have that minus 7 on the end, so 6 minus 7 gives me a negative 1. So all of that simplifies down to simply a negative 1 as my answer. Most of us are familiar with having a bank account or a checkbook or something like that, and these positive and negative integers go right along with the concepts you need for keeping your checkbook balance and making sure it stays above 0. So if I deposit, so this is going to be a positive thing, deposit $105 into my account, and then I make a withdrawal and I subtract $72 from my account. I'm still good, I think. When I do the estimation in my head, I think I'm still above 0. Now I want to subtract another $29 from my account. So we can do this math and we can figure out what our balance is. I'm going to look at these first two numbers first. 105 minus 72. What do I have left in my account? I have 105 minus 72 is $33. And then I'm going to still subtract this 29. So now I have 33. After I withdrew that $72, I still have 33 left. Now I'm going to withdraw another 29. What do I have left? Well, 33 minus 29 equals 4. I have $4 left in my account. Whew, I have stayed above 0. That's a good thing. In addition to adding and subtracting integers, we want to be able to multiply and divide them. And if we have a problem like this, 2 times 4, where both numbers are positive, we've done this before, 2 times 4 equals 8. What happens if one of our numbers is a negative integer, like the example negative 6 times 8? If one of them is negative, then our answer is going to be negative. So we have negative 6 times 8 gives us a negative 48. If both of the numbers that we're multiplying are negative, like in this example, negative 4 times a negative 7, and I put the negative 7 in parentheses just so I know that that negative belongs with the 7. Now I'm going to have a positive answer. The two negatives multiplied by each other gives me a positive answer, so I have a positive 28 as my answer for that multiplication problem. So keep that in mind. If the signs are both the same, it's going to be a positive answer. If the signs are different, you're going to have a negative answer. Same is true for division. We have negative 16 divided by 2. One of our numbers to start with is a negative, so our answer is going to be negative as well. If they both are negative, both the numbers we start with, so negative 20 divided by negative 4, then we know that since the signs are the same, our answer is going to be a positive answer. So negative 20 divided by negative 4 is 5 as my answer for that. Now we can put these all together in a little bit more complex problems that you're going to be asked to simplify. So something like this, 7 minus 4, that whole quantity squared, divided by negative 3. And our order of operations tell us to deal with the things in the parentheses first. So I'm going to look at this parentheses and say 7 minus 4. What is 7 minus 4? 7 minus 4 is 3. And I still want that squared divided by negative 3. And I'm continuing to write the problem and keeping all of my information straight. So now the next step is we want to deal with any exponents. So we have a squared quantity here. So 3 squared means 3 times 3, which gives us 9, still divided by negative 3. Now we're going to do multiplication and division first. And if we had multiple instances of multiplication and division, we would work left to right. So in this case, we just have 1. So we're going to take 9 divided by negative 3. Since one of these integers is negative and one of them is positive, our answer is going to be negative as well. So 9 divided by negative 3 is a negative 3 as my answer. And I don't have any other simplification to do in this problem. The next one gives us a few more things to think about with our order of operations. So in this case, I have a parentheses within a parentheses that I need to take care of first. So my eyes instantly go to this parentheses inside, but that's the first thing I need to do. So the rest of the problem just gets ignored for now, because I need to figure out what this quantity is inside the parentheses. 4 minus 2 is 2. So I got rid of one of the parentheses, now I'm ready to get rid of the other one. 20 divided by 2, I'm just going to hang on to that for now. And I'm going to deal with what's inside this parentheses. So I have 8 divided by 2, which is 4. Now what? We don't have any exponents, so we're going to work on multiplication and division. If I had multiple multiplication and division operators in my equation, I would work those left to right. I only have one. I have a division sign right here, so that's my first step. So I'm going to say 20 divided by 2 is 10 plus 4. And then I simply go ahead and do all the addition and subtraction working left to right as well. There's only one operator here. 10 plus 4 is 14 for my answer there. Now, we are going to solve some equations where we have a variable. So if we have an equation like this, 6x equals 42, I want to know what x is. What number that I substitute in for x is going to make this equation true? So I can ask myself that question. 6 times what? 6 times what number here equals 42? The way I'm going to solve this is I want to get the variable all by itself. So I'm going to divide both sides of the equation by the number 6. And as long as I do it to both sides, that's a fine thing to do. So if I take 6x divided by 6, I simply have an x left on the left. And then I have 42 divided by 6 on the right, which is 7. So we were asking ourselves, what number makes that equation true? And the number is 7. 6 times 7, which we had signified as an x here, 6 times 7 equals 42. So we have solved that equation. X equals 7 in this case. We can also have something like this where we say x minus 4 equals 16. And for this question, we're going to say, what number x that when I subtract 4 from it, I get 16? And some of these simpler ones you might be able to just do in your head, but I'd like you to work through the problem and the mechanics of it on paper. So I would, again, like to isolate the variable. I'd like to get x all by itself. In order to do that, I'm going to add 4 to both sides of my equation. So you can write it this way, or you can write it next to it, however you want to do it. Please write out all your steps to keep it straight. So on the left side, I have x. On the right side, I have 16 plus 4, which is otherwise known as 20. So in this case, my answer is x equals 20. So this is the number. The number 20 is, when I subtract 4 from it, I get 16. So that makes sense. So you want to think through these and think, does my answer logically make sense when we get all the way done with it? We can also solve problems where we have to do a little bit of both the steps we just worked on. So we want to, again, get that variable all by itself. We have 5x plus 7 equals 8, or 5x minus 7 equals 8. So what number x that when I multiply it by 5 and then subtract 7 gives me 8? I want to first add 7 to both sides. I'm working to get the variable all by itself in this case. So I have 5x, 8 plus 7 equals 15. So now I have a new form of my equation, 5x equals 15. At this point, I'm thinking, what number x times 5 equals 15? Well, in order to find that out, we're going to divide both sides by 5. And we get x equals, on this side, 15 divided by 5, which is 3. My answer in this case is x equals 3. That is the number that when I put it back in here makes this equation true, makes it a true statement. Good luck preparing for the Chapter 2 exam. Again, if you need further problems worked through, all of the chapter review test problems are available on a link on the Blackboard website. Go to week 3 and click on the link and you'll be able to watch them all worked out for you. Good luck.